Hey, this is Josh, and so we're going to be doing some math today. And so thanks for coming along for the ride. And like I've said in all the videos, you know, this is a crazy time, and what we want you to do is get the main ideas. And so today's review is just to go through about 5 parts of the chapter and get you ready for the first test. Now, I know this doesn't take the place of being in class and asking questions and all that stuff, but I think that this will be a good enough review that you'll go, okay, I think I'm getting the hang of all of this stuff. And some of it we haven't done for a while. You know, we've been gone for quite some time, and some of this you haven't seen in weeks. So hopefully this is a really good refresher on these topics, and then I'll make a part 2 tomorrow that'll kind of pull this together for the last section of the chapter. Okay. So the first thing, and again, like I always say this, but then I catch people slipping, is I ask basic questions on a test. And one of the test questions that I had on the last one was, what is a function? And then I said, can you give me an example? And people didn't quite get it because they weren't quite sure. So I want to go through and explain what is a function and how can we define it or prove it or show it so that you get the points on the test. You show that you understand what a function is. Okay, so we have our little equation here, f of y, which means it's a function of y. Don't worry about that part. That's algebra 1. We'll get to that later. For now, we just need to understand that we have some kind of equation that matches up to a line. And if I had, like, let's say here, 1/2 x plus 2, I know I have a starting point of 2. I know I go up 1 over 2, and I have this line. Okay, so I draw this super nice, sweet line here. And now I was asked, let's say, like I said, like, what is a function? Well, there's different ways we can define a function. The first thing is you could say that this is a function because it passes the pencil test. And so, again, during this review, if you want to pause the video and say to yourself, oh, what's the pencil test? Pause the video, say it to yourself, then hear what I say, and just see if what we're doing or what we're saying pretty much matches up. Okay? So the pencil test is when you take a pencil or pen or whatever and you hold it up to your line. And the goal of what you're trying to see here is, are there any places where this line crosses over your pencil more than once at the same time? Okay, so if I hold it and I kind of move this up, it looks like it's good. There's no overlapping areas. To give you an example, if I had a line that kind of went straight like that, then it went up, pretty much straight up like that, then it started doing stuff like that. Because I have 2 points here, we'll say this is like, I don't know, 5, okay? If I have over 5 up 2, and then I have over 5 up 8, okay? This is not a function because I have 2 answers when I give when I give the answer or the input value of 5, I get 2 different answers on the output side. So if I were to plug in a 5 right here, I would do half of 5 and then add 2, or let's say, and I would get 2. And then I plug it in again and I get 8. Like, that doesn't make sense. How could I plug in a number for x, right? This is my x-axis. How could I plug in a number for x and then get 2 different answers for y? Like, that doesn't happen, at least not yet. So that's another reason why this is a function, this guy, because anytime I plug in an x value, if I go over a certain amount, I get a new value. Over a certain amount, I get another new value. I don't get any numbers that repeat. So this is a function and it passes the pencil test. This line here does not pass the pencil test because this looks okay, and then it fails because I have 2 points straight up and down right on top of each other, okay? So this is another way to show, like, this is a function, this is not a function. All right? And so that's what I would be looking for on a test in terms of you explaining, like, what is a function or how do I know something is a function. So you could say something like the y value, like the x value can't be repeated. The y values don't really matter so much. These functions really deal with the x value. And if I have 2 answers for x, You know, if I were to make this into a table of values, right? If I have x is 1, y is 6, x is 2, y is 8, x is 3, y is 10, x is 4, y is 11, and then if I go back to 3 again, if x is 3 and y is 17, well, how does that work, right? How can I go over 3 and end up at 10 and then sometimes end up at 17? It can't happen in a function. And so that would prove that this is not a function. Sometimes you'll be given a graph and you'll be asked, is it a function? Sometimes you'll just be asked, what is a function? And sometimes you'll be given tables of values. And when you're given the tables, again, people miss this on the quiz, you got to make sure that as long as you don't, I should say it this way, you can't have any repeating x values, okay? Because if x repeats and you have two different answers for y, then it's not a function, okay? All right. So that was our first topic. Let me erase this guy. Hope you guys are doing well out there in TV land. Things at my house are pretty mellow. In fact, today I was pretty bored. I was actually so bored I started talking to a spider. And it turns out he's a web designer. Dramatic pause. Okay. Get it? Design? No? Okay, well, I'm going to keep on going. I can't tell if you guys are laughing. Speaking of jokes, some people did send some in, so I'm going to try to get at least one or two into this episode and you know, throw in some of that as well, because I know this is math. For some people, this is like your worst class. This is the last thing you want to be doing. So if I can review it and make you smile, then that's awesome. Usually in class, most of my students just kind of look at me and some go, that's not funny, Josh. And I just kind of move right along to the next math problem and keep going, right? You got to try, okay? Let's see here. Representing linear functions. Find 4 solutions to the given equation. Okay, so let's say we have the equation y equals 2x. And you're asked to give 4 solutions to the equation. Okay. If you're asked to give solutions to the equation, what they're looking for is for you to figure out, well, where does this guy go? Okay, where does this guy show up on a graph? Any of these points are considered solutions. So any point should have 2 answers to it, right? This point here should have an x and a y value. So when it asks you for solutions to a linear function, they're looking for you to give ordered pairs. And usually the quickest way to do it with these guys is just to make a table of values. Once again, once you see this, if you want to start working on it, pause the video and see what you get. Then check with me. That's a great way to practice these. So let's see here. I need a table of values. So I have x and y. I'm going to do, and again, you know, I was never really good at this stuff. I always try to pick easy values, numbers that are small. I don't pick decimals. I don't pick super big numbers. I pick things that I can work with, that I can do in my head and not make mistakes. So I'm going to pick 0, 1, 2. Oh, this pen's dying. We'll switch. 0, 1, 2, 3, right? Small numbers. Okay. These are my values for x. So I'm going to plug them into my equation. 2 times 0 is 0. Awesome. Now I plug in a 1. 1 times 2 is 2. 2 times 2 is 4. 3 times 2 is 6. Now, writing it out as a table is not enough. And I stressed this on the first quiz, and some people just got a little haphazard. You got to turn this into a table of ordered pairs, because otherwise you're just giving me a table of values, okay? And usually the book will say something like, write your solution as ordered pairs, which is what it does in our chapter review, and we're finding solutions to the equation. So I need to write these out. So just take a second. 0, 0, 1, 2, 2, 4, 3, 6. Boom, done. All right. Let me erase this guy and let's just do one more of these. All right, let me change the equation here. Got to mix this stuff up, right? Now, the nice thing is I can only make these so difficult. So on one hand, once you understand the wording, you should be pretty set, okay? Let's do 1/2 x minus 4, I guess. I don't know. We'll just pick something, okay? So I make my table of values. Now, some people, because there's a fraction, they like to use multiples of a number or something. If you want to get started, pause the video, try it, and see what you get. That would be awesome. I'm going to do them right here, right now. Again, I'm going to pick small numbers. I'm going to pick 0, and then I'm going to do 2, 4, and 6. Just because they're divisible by 2, and it makes it a little bit easier. So I'm going to kind of cheat a little bit, but that's okay. Okay, so I have 1/2 times my number, and then I'm going to subtract 4 from it. So my first value is 0. Anything times 0 is 0, so I end up with -4. And again, if I'm going kind of fast through these tables, it's because for us, this is a chapter review. So I don't want you thinking like, wait a second, dude, you're going way too fast over this. I do have some other videos in my practical math series that support some of this stuff, but at the same time, for these, I got to think about the guys that were this far along in the book, and so I want to speed up just a tad. I plug in my 2 here, 2, and the reason I pick these whole numbers is just because of this, all right? Anytime you have a whole number, you can always make it into a fraction, and so I do 2/1, right? That's the number 2. It's technically 2/1. When you multiply fractions, you go straight across. 1 times 2 is 2. 2 times 1 is 2. And 2/2 is 1 whole, which just means the answer is 1. 1 minus 4 is -3. Now I'm going to plug in a 4. So I have a 4 here. Okay. 1 times 4 is 4. 2 times 1 is 2. 4, again, we always read our fractions down. 4 divided by 2 is 2. 2 minus 4 is -2. Now, if you're seeing that there's a pattern, -4, -3, -2, maybe the next answer is going to be -1. But let's always do the math. I like when students see the patterns and they start to, take some chances with that stuff. But just be careful, because I want to make sure that you're not just jumping so far ahead. You're like, oh, if I get the first one, then I knew all the rest. Take your time. You have time on a test to do these. Plug the numbers in correctly. And there's a lot of really good math here. There's a lot of good rules that you're going to be applying to Algebra 1. And so I think that it's worth your while to just go through the steps and do them. That's why I always write out my answers here. I write out my work. I do the work, and then I reduce it if I need to. 6 goes on the top, okay? 1 times 6 is 6. 2 times 1 is 2. 6 divided by 2 is 3. 3 minus 4 is -1. Okay? Now, I'm done, right? Wrong. Take it to that next step, right? It says in the problems or in the directions, write it out as ordered pairs. So take these here and just do 0, -4. And then 2, -3. 4, -2. Sorry, it's kind of getting sloppy. 6, -1. Okay? Once you've written it out, you are done and you're all set. Moving on to the next topic. All right. So like I said, I've had some crazy times here. Things have been a little bit, wild. But the weather's been decent, and so, I can't complain too much to be stuck in my house all day. But, I was playing this word game with my kids, and they told me, they said, Dad, the easiest word to spell in the dictionary, or just the easiest word to spell, is the word icy. And I was like, huh. And then I thought, well, now that I look at it, I see why. Get it? I see why. I see. No? Okay. Maybe. Okay. Anyways, moving right along. Hopefully you're getting something out of these jokes. Maybe not. Maybe you're just kind of not really sure what this guy's doing. But either way, we'll just keep on going, okay? The next thing here says to constant rate of change and slope. Find the slope of the line that passes through each pair of points. And so they're going to give you a set of points, and then you got to use your formula. This is where I always encourage students, if you're taking a test and there's a certain formula that you need, walk into the class saying it in your head over and over and over and over. The minute you get your test, write it down on the test somewhere on the back sheet. Who knows? Somewhere. Write down the formula as fast as you can, and then boom, you have it, and you don't have to have it memorized. And then you can use it for the rest of the test. The formula for slope of a line when you're given 2 points is m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now again, if you're not sure how to use this, I do have other videos, how to come up with the formula, why we're using it, but this is our chapter review, so I'm just going to tell you this is the formula. And then let's get some ordered pairs and kind of work through this and see what we get. So let's say I get ordered pair like 1, 6 and like, I don't know, 5, 8, okay? Whatever. I always encourage students, once you have your ordered pairs here, I always say label them, right? We know this is X and this is Y. This is X, this is Y. And then from there, I label them as the first set of points and the second set of points. All of this stuff is helping you set yourself up for success. If you're taking shortcuts and not doing all this, that's when people make mistakes. So be careful. Yes, in the beginning, you're probably more prone to make mistakes. So why not give yourself an advantage of writing this stuff out and then labeling it? So now all you need to do is plug them into a formula here. Y sub 2, well, which one is that? Oh, it's right here. What do you know? It's an 8. And minus y sub 1, which is a 6. Okay, I can fill that in. I have a fraction line here. X sub 2, what's that number? It's a 5. And then x sub 1 is a 1. 8 minus 6 is 2. And 5 minus 1 is 4. From there, you're good to go. Now, if you have a class where you have a calculator, use your F to D button on those Texas Instrument TI-30Xs, whatever they're called, that are made in Texas, and figure out what to do here, right? 2 over 4, or 2 divided by 4 is 1/2, of course. But, you know, if you're not sure, use your calculator. Use that fraction to decimal button and reduce it down. So I end up with a 1 over 2 as like my final slope. Most of the time in the beginning, I would accept this as a perfectly good answer because you've shown me that you understand the topic and the concept. You understand that there is a formula, we're plugging things in, and we're coming up with an answer. The last thing I want to do on a test is I want to see students drawing their own graph and then trying to figure out what this slope is. Believe it or not, people do it, and I don't know why. Like, they'll figure out, oh, well, let me go over 1 up 6, and then over 5 up 8, or so, I don't know, where are these? Over 1 up 6. What was it? Over 1 up 6, and then over 5 up 8. And so you have these points like here and here, and you're trying to figure out, like, what is my rise and my run based on these lines that you drew that are awful. Don't do that, okay? All that's going to do is get you through this test. The formula is going to get you through part of Algebra 1. Because this is great and all, but like, what happens when I make these numbers like 2.4 and like 5.97? Like, good luck graphing 5.97 on this little graph you just made on a blank piece of paper. It's not going to work. Yet people try it, and I don't know why. Use the formula, plug things in. The numbers are going to get bigger. There's going to be square root amounts. It's going to be decimals, negative numbers. Like, it's going to get crazy. So you should focus on the formula versus trying to draw this on your own so that you can then figure out, like, what is my rise and my run? What is my rate of change? Okay. So this is how you do these. I guess let's do one more. Let's plug in some negative numbers just to kind of see what happens and make sure we're all together with that. Let's see here. How about 3, -4, and -1, -1. Okay? All right. So the formula is here. I'm going to label this guy X and Y. And again, if you want, pause the video, do this problem, and then watch it and see if you get it right. I always think you guys learn so much more by trying and failing versus just watching me do this, right? This is not edutainment. This is not like, go, Josh, go, Josh, go. Like, I get nothing out of solving this, right? Other than some personal satisfaction, I guess. I don't know, that I can do a math problem. But for you guys, it's actually worthwhile because you're taking your knowledge about this formula and applying it to this problem. And you're going to need this next year. If you're in pre-algebra right now, you're going to be using this formula next year. You might as well learn it now. Okay, let's plug in our stuff. Y sub 2, my number is -1. And there's a minus in the formula, okay? These minuses aren't going to change. The only thing that's going to change is these numbers over here. And so then I have y sub 1 is a -4. Okay, in class, I do a lot of these dot makings here like that, and I go around, and it's kind of loud and annoying in class, but I do it because I want the students to remember that the symbol or sign in front of the number goes with it. So we have -4. So I'm just going to write that out like that, okay? And then I have an x sub 2 here, so I have another -1, and let's see here, x sub 1 is a 3. Okay. Before I do my calculating, let's make sure I just bust through any of these negatives because that's going to change some stuff. A negative times a negative is positive. Okay? So we have -1 plus 4, right? And if you're not sure how I did that, I have other videos, or think about it. A negative times a negative is positive. So I have -1 plus 4 gives me 3. And then over here, I have a -1 minus a 3. Now, for some students, that just freaks their brain out because they have negatives and negatives. So if you look at it this way, you know, like let's say this was 0 and -1. I have -1, okay? And then I have -3, right? If this was a number line, this is positive, negative. I'm going to go -1, 2, 3 more units, okay? For some people, this is the best way to help them with the negatives, is just to draw it and then move on the number line to the new answer. For some people, they like to say, oh, well, this is the same thing as -1 plus -3. And if you don't understand that trick, just watch it again and see what I did. But I'm just changing it and moving the negative sign next to the number. Because for some people's brains, it's a lot easier to say, oh, instead of -1 minus 3, they can just say -1 plus -3 is -4. When you write your answer like that, it's okay having the negative sign on the bottom. I personally give full credit on that because, again, we're practicing the process here. We're not practicing, can we nitpick and put the negative sign in the middle or on the top or whatever, right? We're working on the process right now, and so I would consider that as awesome and giving you full credit. All right. So as I'm erasing this, let me kill another couple seconds here. This was something I heard from one of our students. He said that at his house, you know, they were kind of strapped for things to do. And so they ended up moving things around in their kitchen. And they put the freezer next to the refrigerator. And I said, well, what happened? And he said, well, now they're both chilling. Okay. So get it? Chilling? No? Freezer, refrigerator? Okay. Hopefully that made sense. If not, okay. So be it. This is the last topic that I want to touch on today. This has to do with direct variation and slope and Y-intercept, okay? And so we can tell when something has direct variation for two reasons, okay? The first one is if you're given a graph, all right? Let's say I have a line like that, and let's say, ran out of my green, let's say I have a line like that, okay? Which one is direct variation? Which one is not? Well, in class we discussed this. Anything that has direct variation has to start at the origin. If it doesn't, it means that it's some kind of situation where, like, let's say it costs $2 to go into the amusement park and then $1 for every ride. So if I were to start here and go to the amusement park, right, I have to pay $2 before I even like do a ride. Then it's just $1 for a ride, $1 for a ride, $1 for a ride. Whereas if I just go to the amusement park and there's no like entrance fee, in that situation, it's just $1 for a ride, $1 for a ride, $1 for a ride. So this situation here does not have direct variation because it doesn't start at the origin. There's like something that has to happen and then I can start my line, okay? And so you'll be given different things where you're given like a set of numbers or a pattern that you have to work through and figure out if it has direct variation or not, okay? And so just be careful with these guys, okay? Anytime, if you're given a graph, this is pretty easy to determine, right? Anything that starts at the origin is direct variation. Anything that doesn't start at the origin does not have direct variation. If you're given a formula, y equals 3x plus 7, does this have direct variation? No, because in order to graph this, I have to move up the y-axis to 7 and then start drawing my line. And again, this gets back to quick graphing and stuff that we've already done in the chapter. If it asks you something like, well, I should say, what if I have a formula like y equals 9x? What about that guy? Does this have direct variation? Yes, because it starts at the origin. There's no starting point here, and I just start to slowly move up at a rate of 9, or 9 over 1. Could you prove it in another way? Yes. I could make a table of values here. And when x is 0, well, what does y equal? If x is 0, 9 times 0 is 0. So my first ordered pair to start this guy off is 0, 0, which is right there at the origin. If I did 0 here, 3 times 0 is 0, and that's great, but then I have to add 7 to it. And so because I'm adding an amount to it, my numbers aren't going to be the same, and so therefore this is not direct variation, okay? So I wanted to make sure we talked about that in this first segment of our chapter review. The next part, I want to go through, what is this? Graphing an equation using slope-intercept, and then solving the systems. Now, I just did a lesson on solving the systems by graphing and algebraically. And so the second part of the review, I'm just going to do a bunch more problems of those with you. Now I can probably start listing a couple over here and have you go through them. But these are some of the topics that we haven't done in a while, and I just wanted to really make sure that when you see it, you go, oh yeah, that's right, direct variation. Oh yeah, function, pencil test. I wanted to make sure that we go over that stuff so that you remember all these parts. Okay, so send me more jokes, send me more questions. Thank you for watching, all that good stuff. And I will see you real soon. Keep working hard at home, and I'll be in touch. Thanks a lot.